Hello everyone, we are going to learn computer for exam Epfo. This is going to be a very short video. This PDF has just 24 pages, 24 slides, and I've made this PDF as per my convenience, and you'll get this PDF if you will ask. I'll provide it free of cost, don't worry. So let's begin. First we learn about evolution of computer. First we had abacus computer, first introduced in China, which was able to perform plus and minus, addition, subtraction, and second it was Napier bones. So one of the question comes is, who has Rhabdolgia technology? So this is Napier bones, which is able to perform multiplication and divide. Third we have Pascaline. Fourth is Jacquard looms, which is able to do punch card, which has the feature of punch card. And now comes analytical engine, that is having storage device. It was introduced by Charles Babbage. He is known as the father of computer. Then tabulating machine by Hermann Hollerith. This video would appear as a factual one, but you have to do it because for exam it doesn't require a deep knowledge. We just have to clear the exam, so I've made it a bit factual. You might find it factual, but it's doable. So where were we? Yeah, tabulating machine by Hermann Hollerith. Turing machine made by Alan Turing, the father of modern computer science. So EDVAC and ENIAC. It is the first general purpose electronic computer. And then comes integrated circuit, that is IC. The combination or the sum of integrated circuits is called transistors. John von Neumann, he made a stored program architecture, and if we give input to it, to the CPU memory, and it gives output. Bill Gates and Steve Jobs popularized PCs and operating systems. So technologies are vacuum tubes, that is first generation. Second generation, transistor. Third generation is IC, integrated circuit. This one. Fourth generation is microprocessors. Fifth generation is artificial intelligence. So I made a trick to learn it. This is Vatica MA. Okay. Yeah, I hope you are able to see it. Yeah, so I made a trick for it. It's Vatica MA. This is vacuum tubes. T, transistors. ICA, Vatica. It's integrated circuits. MA, microprocessors. Fifth generation AI. Okay, so about the vacuum tubes. Vacuum tubes are very large. It has punch cards, paper tubes, printouts, machine language. Second is the transistors, which has magnetic tape. Printers, its examples are IBM Longines 1401. It has assembly language. Then third generation, it is integrated circuits with keyboard, monitor, hard disk, and high level language. Fourth generation with microprocessors. It has portable PC, laptop, floppy, hard disk. It has high level language plus graphic user interface. Then comes fifth generation with artificial intelligence. It has robotics, quantum computers, nanotech, natural language. The language is natural. It has cloud storage, example Google AI, and it has the features of gesture recognition like features, which our phones have. So here comes, first commercial computer was UNIVAC. This can be asked in the exam. First commercial computer was UNIVAC. So computers can be divided into two, this hardware and software. Hardware are input, output, communication devices, storage, memory. And what constitutes an input? Fine. Input constitutes keyboard, light pen, webcam, mouse, scanner, joystick, graphic tablet. And output devices constitutes monitor, display screen, LED, OLED, LCD, inkjet. Inkjet is an example of printer. It constitutes output devices constitutes all printer. speaker, projector, plotter, banner maker. I hope you all know this. This is very basic, we have read in school. So about the functional keys, it is F1 to F12. That means we have 12 functional keys. Trackball is another name for mouse. Scanner, what does scanner do? Scanner converts physical documents to digital. Mic, biometric devices, these are examples of input. You can see the same color, input. So mic, biometric devices, scanner. OCR, optical character recognition, it print text to editable text. ये printed text को editable text में convert कर देता है. This is MICR, magnetic ink character recognition. ये बैंक्स में यूज होता है चेक प्रोसेसिंग में. चेक के साइड में एक स्कैनर टाइप्स जो होता है, जो हम लोगों को समझ नहीं आता, बट इट इज़ रिकग्नाइज्ड बाय कंप्यूटर्स. OMR, optical mark recognition, it is used for reading answer sheets, we know it very well. CRT, so this is the green colored one, are examples of output devices. Okay, remember this. These are examples of output devices. CRT, cathode ray tube. LCD, liquid crystal display. LED, liquid emitting diode. OLED is organic light emitting diode. इनपुट आउटपुट कॉम्बिनेशन डिवाइसेस भी हैं हमारे पास, जो दोनों के फीचर्स हैं जिनके पास. ये क्वेश्चन आ सकता है कि इनपुट डिवाइसेस कौन से हैं, आउटपुट कौन से हैं, विच डिवाइसेस आर कॉम्बिनेशन ऑफ बोथ. सो लेट्स सी. टच स्क्रीन, बिकॉज इट टेक्स इनपुट एंड गिव्स आउटपुट टू. Second is modem. This, what is modem? Is modulator, demodulator. Modem. Third is network or Wi-Fi card, CD, DVD, Blu-ray drive, fax machine. Fax machine क्या करती है? Print, scan and copy. Fax machine, print, scan, copy. Okay. External storage devices like pen drives. Headset with mic. Headset, input, mic, output. Okay. VR headsets, AR devices. Sorry. CPU. CPU is known as the brain of computer. It was introduced by John von Neumann. CPU is made up of microprocessor chips. CPU has serial processing. Microprocessor is divided into core. One microprocessor is divided into multiple cores. And these cores are further divided into threads. Okay. And why is it divided into threads? Because to help core perform multiple functions simultaneously. So what are the components of CPU? Control unit, arithmetic logic unit, which performs logic work. Third is memory unit or registers. It is a temporary storage during processing. Then CPU has no permanent storage unit. This is one of the important things. CPU has no permanent storage unit, and CPU's memory can be divided into registers, which is the fastest storage in the computer. Registers, fastest storage in computer. Then comes cache, and both of these are temporary. Types of CPUs: CISCs, complex instruction set computers, reduced instruction set computers. This reduced one is the fast type of computer. Then comes third, microprocessor, which is a modern CPU. Core, physical processing unit inside CPU. It can execute one task. That's why the core was divided into threads to perform multiple functions. Remember? First microprocessor was Intel 404, introduced in 1971. This is GPU, graphic process unit. It is the soul of graphics. GPU, graphic processing unit. It helps CPU. It is used for parallel processing. Multiple bits transfer हो पाते हैं इससे. Father of CPU, Federico Faggian. And who was the father of computer? Comment down. Who was the father of computer? Yeah, Charles Babbage. So where were we? Yeah. GPU is the soul of graphics. It helps CPU. Father of CPU is Federico Fajan, head of Stanley Mazer. They also helped Federico in designing CPU. Father of CPU is Federico Fajan. Okay. So speed of CPU is measured in hertz. Okay. Performance of CPU is measured or divided into two parts, kips and MIPS. This kips is kilo instruction per second and MIPS is million instruction per second. And supercomputers is divided into flops, floating point operation per second. Flops is floating point instruction per second. Wait, I'll zoom it for your convenience. Just a minute. I hope it's visible now. Yeah. Supercomputers has flops, floating point operation per second. CPU components include arithmetic logical unit, control unit, registers, which is memory. So CPU, what function CPU can perform? Fetch, decode, execute, store. Fetch, decode, execute, store. So, and what is hyperthreading in CPU? Creating virtual cores. Hyperthreading in CPU, see this, hyperthreading, creating many threads. Okay, hyperthreading in CPU, creating virtual cores to perform multiple tasks. Yeah. So I'll make you understand this table first. 1 bit, which is the smallest unit, which can be measured in 0 or 1. Okay. Second is the nibble. 4 bits equals to 1 nibble. Byte, 8 bits equals to 1 byte. Kilobyte has 1024 bytes. You have to learn this table. It is asked several times. 4 bits equals to 1 nibble. 8 bits equals to 1 byte equals to 2 nibble. I have written this for your convenience. And to learn this, I have made one short form. You might find it weird. So it is Bombay National Bank से कल मेरे घर तेरे पापा extra Zepto coin ला ये. Okay. Bombay National Bank से कल मेरे घर तेरे पापा extra Zepto coin लाए. So let me zoom it. Bombay is for bits, national is for nibble, bank is for byte, kal is kilobyte, mere is megabyte, ghar is gigabyte, tere is terabyte, papa is petabyte, extra is exa, Zepto is zeta. So this table continues here. This table is given till terabyte, so it exceeds till petabyte, exabyte, zetabyte, and lie is this is y, zotabyte. You know how much it stores? It generates yearly total amount of data which is impossible to store. This zotabyte. It is the largest unit. Smallest one was bit. Largest is zotabyte. I hope it's visible. Yeah. So I don't think there is anything else left to make you understand this. And yeah, remember this golden key. 1 byte equals to 8 bits. It will help you. Yeah. Memory of computers. Memory is the storage space. It stores data and instructions, and memory is divided into primary. Primary storage is in motherboard, and secondary. Primary memory is fast but volatile. Its components are RAM, which is temporary volatile, and RAM is further divided into static RAM, dynamic RAM. RAM is in motherboard. Remember this, RAM is in motherboard. Then ROM, cache, registers. These are components of primary memory. Single bit constitutes of 0, 1 stored in flip-flop. Collection of flip-flop is called registers. Collection of flip-flop is called registers. Static RAM. So let's understand the difference between static RAM and dynamic RAM. So these are the bases of differentiation. I made it very easier. Static, so data stored. Static RAM has flip-flops to store data. Dynamic has capacitors to refresh. Static RAM does not require refresh. Dynamic RAM requires refresh. And speed. Static RAM is very fast. Dynamic RAM is slow. On the basis of cost, static RAM is expensive. Dynamic RAM is cheap. Density. Static RAM has low density and dynamic RAM has high density. Power consumption. Static RAM has low power consumption and dynamic RAM has high power consumption. Use. So static RAM is used for in cache memory, registers, and dynamic RAM is used in RAM main memory in PCs. Each cell. Static RAM has 6 transistors and dynamic RAM has 1 transistor plus 1 capacitor. Remember this. Each cell. Static RAM has 6 transistors and dynamic RAM has 1 transistor and 1 capacitor. And about the design. Static RAM has complex design and dynamic RAM has simple design. So let me summarize it. Understand it yourself. See, static RAM, which is very fast, so it would be expensive. It would consume low power. These are something basic things you can even assume. It does not require refresh. So these are some positive components. Fast, does not require refresh, expensive, low power consumption, complex design. Similarly, dynamic RAM, it is cheap, slow speed, requires refresh, high density, high power consumption, and simple design. Okay, some of the obvious things that now you could remember. Synchronous dynamic RAM, this is called SDRAM. Synchronous dynamic RAM with CPU clock. It requires refresh. So now we'll come to ROM, read-only memory. It is non-volatile. It is slower than RAM. It contains read-only memory. This is ROM. It contains firmware. Firmware is a software. So ROM contains firmware, software which is stored. Firmware is the bridge between hardware and software. Now we'll come to BIOS, which is a component in ROM. Basic input output store. PROM is programmable ROM, which is a blank chip and it is non-erasable. So learn these differences. PROM, programmable ROM, which is a blank chip and it is non-erasable. Okay, it can't be edited. So EPROM, so we add this erasable component. So this erasure could be possible by exposing it to UV light. Then EEPROM, okay, E is electrically erasable programmable ROM. So using electricity to erase is a better version of using these UV lights. So this is better one. By electricity it is faster, flexible. Example, memory card, flash drives. So now cache memory. It is very high speed. Cache memory is very high speed memory. So RAM, then cache memory, then CPU. How does computer takes memory? First it searches in RAM, then it goes to cache memory, then it goes to CPU. Cache memory is a temporary storehouse. So now comes register memory. It is very tiny storage. It is inside CPU. So fastest memory, tiny storage है, तो इसलिए fastest है, and it is very small size. Okay. So what is volatile? कौन सी है हमारी? Register, cache, RAM. और non volatile में है ROM, that is read only memory, pen drive. These are non volatile. Volatile are register, cache, RAM. Non volatile are pen drive and ROM. So primary memory constitutes of ROM, RAM, register, cache. This is written again just to recall. Primary memory, ROM, RAM, register, cache. So cheapest is the hard disk as it is very slow. If you are asked what is the cheapest storage device, it is hard disk as it is slow. So this is a CPU. It constitutes registers, that is for storing. Then it goes to cache, then it goes to RAM to search data, to search storage. So let's learn features. These is register, cache, RAM. Okay, I'll rewrite it when I'll post it. Okay, features. So location, register is located inside CPU, just as we see. Cache is between CPU and RAM. Okay, and RAM is located on motherboard. We learned it earlier. Speed, registers are fastest, cache is very fast, and RAM is fast. So among all of these, cache is the fast. So size, registers have very few bytes, cache few MBs, and RAM few GBs. Remember, bytes, MBs, GBs, gigabytes, megabytes, and bytes. Functions, register holds data in execution, cache holds frequently used data, and RAM is the main working memory. RAM, main working memory. So registers data is accessed by CPU directly. See, CPU directly. Cache data is accessed by CPU automatically, and RAM's data is accessed by CPU via cache. CPU cache के through RAM से data लेता है. Yeah. And examples, read it. I've even written the full forms. PC is program counter, AC is accumulator, IR is instruction register. So main memory passes data through buses to CPU. Okay, it is one of the PYQ. Main memory passes data through buses to CPU. To increase speed of computer even if had high storage. To increase speed of computer even if it had high storage, so you should have high RAM size. कंप्यूटर की स्पीड बढ़ाने के लिए क्या करना चाहिए, जबकि कंप्यूटर के पास स्टोरेज तो है, स्टोरेज है बट स्पीड नहीं है, तो उसके लिए क्या करेंगे, हम रैम साइज इंक्रीज करेंगे जिससे कि फास्ट वर्किंग होगी. CPU find data in cache which is called cache hit, and if it does not find data here, if CPU does not find data in cache, so it is cache miss. So CPU fetch data in this sequence. Okay, सबसे पहले CPU goes to registers because it is inside CPU, then cache, then RAM. See, register, cache, RAM. Okay, just learn this sequence. This is for smallest, fastest, and expensive, and data fetching sequence. This is the same sequence. If you are asked which is the smallest, then registers, cache, RAM. If you ask fastest, registers, cache, RAM. Expensive, even expensive also, and CPU fetch data in the sequence of registers, cache, RAM. Remember this. Then comes virtual memory. Virtual memory act as additional RAM. It is a part of hard disk. Memory address register, MAR. It contains the address of location in memory. So there are 7 types of registers. All of these are in CPU because register is in CPU. Yeah, 7 types. Accumulator, short form AC. Accumulator, what does accumulator do? It stores result of arithmetic logical operations, logical unit. It stores result. Accumulator. Memory address register, address location, not visible register भी कहते हैं इसे, MAR. Memory address register को not visible register भी कहते हैं. मेमोरी डेटा या बफर रजिस्टर, इट इज MDR, डेटा टू या फ्रॉम मेमोरी. ओके, प्रोग्राम काउंटर, इट इज एड्रेस ऑफ नेक्स्ट इंस्ट्रक्शन. Instruction register is what to perform current instruction executed. It instructs computer of what to perform. Instruction register. So it is bit correlating with their names, these functions. Input output register, this is I/O, store temporarily between CPU and input output devices. Temporary register, TR, store temporary result or intermediate data. So now comes secondary memory. इसे external auxiliary storage या permanent storage भी कहते हैं secondary memory को. Primary was temporary, yeah, secondary is permanent. So it is non-volatile, it is slower than primary, of course. It has long-term storage, it has large capacity, GB, TB and PB. It is very cost effective. So types देखते हैं हम secondary memory के types. First is magnetic storage, magnetic pattern to store data. It uses magnetic pattern. Example, hard disk, floppy disk, magnetic tape. Second is optical storage. It uses laser technology. Example, CD, DVD. These are digital versatile disk. DVD, digital versatile disk. And CD, DVD. Both of these use red laser ray. And one of the thing is Blu-ray disc, which is better than red laser ray. Third is solid state storage, semiconductor storage. It uses flash memory. It is fast, durable. Example is SSD. This is solid state drive, USB memory card. Now comes cloud storage. It is online. It is a cloud storage. Very common nowadays. It is accessible online via internet. Example, OneDrive, Dropbox. It is slowest data access time. Slowest data access time is magnetic tapes. So magnetic tapes has slowest data access time. So CPU is connected through input output channels and controllers with secondary memory. CPU is connected to secondary memory through input output channels and controllers. Number systems in computer. Binary number system uses 0, 1, so 2 digits, so its base is 2. It is used in programming, memory, logic gates. Okay, decimal number system is from 0 to 9, so its base is 10. It has 10 digits, so base 10. User interaction, input output में काम आता है. Third is octal number system. It has 0 to 7, so base is 8. Octal number system, base is 8. It is used in early computers, Unix file. Fourth is hexadecimal. Hexa is 6, decimal is 10, so the base is 16. Hexadecimal number system, base is 16. It is used in debugging, memory address, web color codes. Now comes conversion of number system. There are 12 ways of conversion. I don't think this is relevant, so let's skip it. Yeah. Computer network. What is computer network? It is a group of interconnected devices that communicate and share. Resources like data, files, internet, printers, etc. through transmission media, यानी कि wire या wireless, both. Remember, wire or wireless. Let's read again. Computer network is a group of interconnected devices that communicate and share resources like data, files, internet, printers through transmission media, that is wire or wireless. So let's learn types of computer networks. Personal area network, it is of around 10 meters. It is used for single persons. It is small area network. Example, Bluetooth hotspot. Bluetooth uses which technology? Infrared. Okay, USB cables, hotspots, wireless and wired, both. Personal area network. Now comes second, local area network, LAN. Connect computer within a limited area. Example, computer labs in schools, cyber cafe. It has very high speed, around 1 Gbps. Uses coaxial or twisted cables. It also uses Ethernet cables or Wi-Fi. It is very low cost. It has high security of data, and it covers area from 100 meter to 2 kilometer around. So it is local area network, 100 meters to 2 kilometer. Third is the metropolitan area network, MAN. So it uses multiple local area networks. It uses multiple local area networks, metropolitan area network. It has cable TV, citywide public Wi-Fi. It is used in university campus. It covers up to 50 kilometer. It is less secure in terms of data privacy. Microwave connection, use fiber optics. It is slower than LAN because it is very wide, so it is obviously slower than local area network. Then comes fourth, storage area network. It's centralized data, example cloud provider, data center of banks. It is very high speed and it has backup. Storage area network, it has centralized data, it has devices connected. Cloud provider. Okay, so virtual private network, it is secure and encrypted connection, example employees accessing office network from home. It uses tunneling protocols. So summary table for these: personal area network, examples Bluetooth hotspot. Medium is wireless. LAN, local area network, used in building campuses, example office, school. Medium is wired or Wi-Fi. MAN, metropolitan area network, area covered is city level, example cable TV, metro Wi-Fi. Medium is fiber microwave. WAN, wide area network, its area covered is country or world, example internet banking. Or medium is satellite and fiber. LAN, wireless LAN. Okay, local wireless. Wi-Fi network, it uses Wi-Fi network, it uses radio waves. SAN is storage area network, area covered is data center. Server is storage, example is server storage. Medium is fiber channel. WPN is virtual private network, it is on global level, it is very secure, example is remote work. Medium is internet and it is encrypted, secure. So now we'll come to computer network topology. Physical or logical arrangement of computers, cables, devices in a network. It is just about the arrangement, it is named on that. We'll do it quick. So there are 6 topologies. Bus is bidirectional flow. See, this is one bus 1, bus 2, bus 3. So it is connected to a single. It has a bidirectional flow. Carrier sense multiple access, that is CSMA, carrier sense. Okay, so collision avoidance and collision detection. It has 2 features. Its cable is twisted coaxial cable and it is easy and cheap because it is connected to the single cable. It is slow, it can have maximum 30 nodes. This is the limitation of it. Example क्या है? Ethernet network. Second is the first one was bus. Second is star. It is easy to install, 100 Mbps. Example is LAN, local area network. It is mostly used. See, this is the hub, the center one for data transmission, and these are the connected devices. Center one is hub. तो इसकी limitation क्या है कि अगर hub में कोई problem आएगी, any problem in the hub would cause problem in all of these. So it requires more cables to connect each of these separately, and the cable used is twisted or resistor. Example is resistor cable का example is jack 45. Third comes the ring. See, all of these are connected. It is larger than bus. It is an endless loop because we don't know where it is started and from which is one is the end. Example token ring network, coaxial cable. It has low cost. and ring 1 is unidirectional data flow. Fourth is mesh. See, each one is connected to every one, a star type, but multiple stars. See, this one is connected to this. Okay. Mesh 1 is have high redundancies. It is highly secure, expensive. It has more cables because each one is connected to all of these. It is having high traffic support, complex reliability. Example is wide area network. It is fastest, best in point-to-point connection. Example, it is used in military use. So which one is used in military use is mesh. Then comes tree topology. It is like a family tree, if you have seen, hierarchical structure. This one, first one is the root. This first one is called root, and it is made like a family tree. Each one interconnected to the first one. Yeah, and these are known as the branches. So tree is a combination of bus and star. It has high number of cables. Examples, corporate or universities may use hota hai. So if I ask you a question, there are 6 computers. So what will be the number of cables used in mesh? If we have 6 computers, so what will be the number of cables used in mesh? So we will find it by n minus 1 by 2. So we have 6 computers, n minus 1 is, n is 6, n minus 1 5, by 2 it comes 15. You might have read this formula in maths. So 6 topology is hybrid. It is flexible. It has 2 or more typology combines. It is used in big organizations, hybrid one. So now comes computer networks. This is ARPANET, Advanced Research Project Agency. Advanced Research Project Agency Network. Advanced Research Project Agency Network. It is the first generation. It is point-to-point connection. Second generation is the local area network. Third generation is the WAN and internet. You don't have to remember the second and third generation. Just remember the first one. This is ARPANET, Advanced Research Project Agency Network. So some of the important inventions. 1971, email by Roy Tomlinson. 1974, the term internet was coined. 1984, TCP or IP model by ARPANET. OSI model. Okay. Fourth generation was the World Wide Web. 1990 by Berners-Lee, World Wide Web. We searched on www. This is by Berners-Lee, 1990s. Vint Cerf and Bob Kahn introduced the TCP and IP protocols. So let me introduce you with TCP IP protocols. So it is transmission control protocol or internet protocol. So it has 4 layers. First one is network access layer. Second is internet layer. Third is transport layer. Fourth is application layer. So to remember the sequence, I have made a short form NITA. So this is first is network access layer. Second is internet layer. Third is transport layer. Fourth is application layer. Vint Cerf and Bob Kahn introduced the TCP IP protocol, and it has 4 layers. Okay, so Robert Metcalfe invented Ethernet, 5th generation, IoT, cloud and wireless, obviously, and ISO is the maker and OSI is the model. Sorry. OSI is the Open Systems Interconnection. OSI, Open Systems Interconnection. It has 7 layers. So if you are asked what is the number of computers, if you are given the number of computers and you are asked the number of collision domains, so they are equal. If you have 6 number of computers, so you have 6 number of collision domains. Yeah. So this is the same which we have written here. All of these same. And now we'll come to 7 layers of ISO OSI model. ISO is the maker, OSI is the model. Yeah, 7 layers. First layer begins with physical, then data link, then network, then transport, then session, then presentation, then application. So physical, data link and network are hardware. Transport is hardware and software both. It is called the HUD. And session, presentation and application, these are software. Okay, so physical layer is wired, wireless, topology and transmission one. It stores data in bits. It devices used are hub, cables. Devices used are hubs, cables, repeaters in physical. And function is single transmission through Wi-Fi. Data link is node to node delivery. Data link data unit. Data link में data unit is frame. Devices are switch and bridge. Function is for error detection, MAC, address and correction. Then comes network. इसकी data unit है packet. Device is router. You might have seen. Function is routing, IP addressing. It is the best path. It determines the best path. IP address determines the best path. This is the network. Transport, which was hardware and software both. Remember, it is TCP protocol, UDP. These are examples of it. Transport uses segmentation for data unit. The device is gateway, and it provides end-to-end delivery. Error-free data होता है यहाँ पर. Transport में error-free data. Then comes session or synchronization. Data unit is data, device is gateway, and session management is a checkpoint for long data transfers. Session or synchronization is checkpoint for long data transfers. Presentation or syntax or translation. Presentation, syntax and translations uses data unit as data. All of these software devices. So where were we? Presentation, syntax, translation, data. Devices gateway. What is presentation function? Format conversion, encryption, compression, formatting. And application layer. This is the 7th layer. Application, data unit is data again. Device is host. Function is it does user interface interaction and it is closest to the user. So some of the short forms, because it is widely used. FTP, file transfer protocol. DNS is domain name system. USB is universal serial bus. I've just written it again. This is the same table. Yeah. So let's see network devices. Hardware component that connect computer and other electronic devices. What are network devices? These are the hardware components that connect computer and other electronic devices, therefore called computer network. Fine. Data transmission, routing, communication, network management. These are the functions of network devices. Types are NIC, network interface card, Ethernet card, या network adapter, LAN card. These are other names of it. It converts parallel form of data into serial form. NIC converts parallel form of data into serial form. It has unique MAC address. Example is Ethernet Wi-Fi card. First was NIC. Second is hub. It connects multiple computers. It does not have any filter. So let me explain what is this filter talking about. So if it is the hub, it's connected to this network, and the data required to send is if the data is required to be sent to this one, but the hub sends the data to all of these, so it does not have any filter. Okay, hub is also called the dumb one. It broadcasts data to all devices. It works at physical layer. It is not secured and it's very slow. Work at physical layer means it is also called half duplex mode. Third comes switch. It is a data link layer, stores MAC address. It is highly secure and faster. It has low traffic. Switch has low traffic, and it is called intelligent device. Why intelligent? Because it sends data to the required one only, not everyone. Then comes bridge. So these are the devices, and the bridge connects all of these. The bridge network uses bus or star. It connects two local area networks and filters data, reduces traffic. Then comes router. It defines path. Router defines path. It addresses translations at network layer. It is at layer 3. See, layer 3, network layer 3. Okay. Yeah. Layer 3 router defines path, address translations at network layer. Example is Wi-Fi, broadband. It uses IP address. Sixth one is the gateway. It is a software. You remember the 5th, 6th, 7th were softwares in the table. Gateway is a software. It connects two different networks. Example, WAN and LAN, wide area network and local area network. It is just an example. It connects two different networks. Example, email, modem router combo. It is a secure traffic management translate protocol. 7th is the modem, modulator, demodulator, modem, modulator and demodulator, digital to analog, converting digital to analog and vice versa. 8th is the repeater. If this is the network, and it can send the data here till 100 meters. So the repeater again resends this again 100 meter to be received by this network. So repeater further amplifies the data. Amplify or regenerate weak signals. It extends the range of network. 9th is the access point. Access point connects wireless to wire network at data link layer. 10th is the firewall, security barrier between internal and external network. It is a traffic filter. It is both hardware and software. Firewall. It is a security barrier between internal and external network. So that's it. I think this much is enough for computer to be done. Thank you. The PDF will be provided. Just text me. Yeah, so I'm signing off. Thank you.